today. We do not have a test this week. Your test is next week. We've got one more lesson. It's just an extension on parallel and perpendicular lines, which we've had a long weekend, so this will kind of be a review / finish. It's not a whole lot of new stuff at all, but again, it's been a weekend. And then we're going to take an exit ticket at the end. We have review day on Thursday. So I've got some activities for us. We got a test review. We got a gym kit. I also have like a slideshow thing, so we might get the whiteboards out and do some of that too. It'll kind of just be some options. And then we will have our test for you guys. It's going to be on Monday, okay? And then we will have some lessons towards the end of the week, even though like it is before a break. We kind of got to keep going so we can get everything done before semester ends. But that is the plan. Test is Monday. We're going to be ready, aren't we? Aren't we? Yes? Nod your head. Say yes. Okay, let's go to page 13 real quick. Where's your notes? I've asked you that like 3 times. I don't think there's a warm-up on here that I can see. Remember, we put your pencil back there. We put your pencil in that little cup back there. So you put it there, and then you can get it back. So page 13, let's just kind of go through our steps real quick talk about parallel and perpendicular. Remember, the only thing that's different about parallel and perpendicular that you have to consider what the parallel or perpendicular slope is. But once you decipher that, then you go to point slope form, and then today we're going to convert. So it's really just a merge of kind of what we've been doing. It's not really that much new. But again, been a long weekend. So step 1 is you have to determine the given slope. So they're going to give you a line. They're going to give you an equation. Might be in slope-intercept, might be in standard. We got to figure out what the slope of that is. We even had some problems on our homework where they gave you a graph, and we had to calculate the slope with a graph. Okay, so that's the first thing. What slope are we given? Then we're going to circle our keyword, parallel or perpendicular. What do we know about parallel lines? Parallel lines have go ahead and fill that in. Same slope. And remember, our little shortcut for parallel is either 2 vertical lines or 2 lines like that. You can use that if you're trying to talk about parallel and you don't want to write out all those letters. So if the keyword says parallel, we find the slope, we keep it the exact same. No change, okay? What if it said perpendicular? What do you do with perpendicular? Perpendicular lines, you flip the fraction, and change the sign. Change the sign. Flip and change, like you said, is what the jingle kind of goes. But you're technically flipping the fraction, changing sign. Miles, do you remember the fancy word for that? You wrote it down on your notes last time. Opposite. Remember? Opposite. Anybody remember the other one?
Oh, it's reciprocal.
Opposite reciprocals. Very good. That's the same thing. So you can put that there. Opposite reciprocals. Okay? So figure out your parallel or perpendicular slope from there. That's step 3, your new slope. Go through the given points. They give you that. You go to point slope form, and then you convert it to slope-intercept form. So last time we really stopped at step 5. So the only thing we're going to be doing is converting. But you guys are like converting all-stars. Okay? So we've been doing that for a while. So that's the flow. We got quite a bit of problems. I think we might just do a few of them here. I might skip some. And then we will going to talk about parallel and perpendicular to the axes, and then we just have some practice to do before our CFU. So go ahead and go to the next page. Let's do number 1. We'll do number 1 together. Okay? So today's goal is to take it all the way to what form? What do the instructions say? Slope-intercept. Okay? Last time we stopped in point slope. We always got to start there, but then we got to convert it all the way. So if you were gone last time, Nick, you were gone last time. Who else was gone last time? Emma? Okay. So if you were gone, here's a quick recap. You'll be able to catch up by the end of this. Passes through the point. So here's our given point. And what's our key word? Parallel. What do we know about parallel lines? Same slope. So again, number 1 has a lot of little answer blanks for you to consider. You're not going to have that. Your stuff's going to be like number 2. We're going to do that. We're going to take all that away, but this is like the process that we're going through. So parallel lines have the same slope. we want to know, we want to be parallel to this guy. Y equals 3/4 x minus 2. What form is that given equation in? What? How do you know? Y equals. Do you know the slope in slope-intercept form, Braden? Do you know the slope when it's in slope-intercept form? Can you see it? What is it in this problem? 3/4. Very good. Okay, so steal that slope. Now, we want a parallel slope. Parallel in. Parallel lines have the same slope, so I'm going to use that same fraction. Okay? And then really, you're done with the other one. You either keep it or you flip it and change it. And then you don't need that anymore. What point do we want to go through? The problem gives us that. What point? -4, 2. And then we're going to use, I'm going to circle here, the parallel slope and the point. And then we're going to go to point slope form. Can you give me your point slope form when you're done? All right, Zig, point slope form. Here we go.
Point slope form? All right.
Yep.
It's y minus 2 equals 3/4 parentheses x plus 4.
Very good. Okay, we still remember that. We've done this a lot. Okay, but remember, you always got to go point slope, and then you got to convert it. Do you guys remember how to convert from point slope to slope intercept? It's been a little bit. Distribute. Very good. So we're going to distribute right here. That fraction's not going to freak us out. We need to write kind of small because I don't have tons and tons of space. So let's see here. We're going to have y minus 2. Y minus 2 is going to drop down. 3/4 times x. Just put those together. 3/4 x. What about 3/4 times 4? 3/4 times. You're distributing, and that's a positive 4. It's kind of bright. What number do we get?
3.
Positive 3. Ethan, did you do that?
I finished working.
Did you get positive 3 when you distributed? You make sure you're showing that step.
I didn't distribute.
Okay, then you didn't do it right. We got to distribute, and then we got to move the number
I
over.
thought you didn't have to distribute.
Yes, you do.
Always.
Okay, so we multiplied that through. Guys, it is very possible. I think this might happen on the CFU, and it might happen on one of these. It is very possible that this guy could be a fraction. Is that going to like trip us up if this guy's a fraction? No, because we have alpha y equals to do our multiplying, to do our adding, to do our subtracting. I've seen a lot of STAR questions when it's just kind of ugly. But this one worked out nicely that it was pretty. And then what do? What's our final step?
Divide.
Not divide in this. We're going to add or subtract because it's y minus something. So I'm going to add 2. And again, I put it to the plain number. What's 3 plus 2? 3/4 x plus 5. Okay, if you have something in slope intercept form, what can you now do that you can't do in point slope form? Has to do with this guy right here. When you have something in slope intercept form, you can now put your equation in y equals. Let's do that. Okay? This is a way that you can, oops, not 34. This is a way that you can check. I love to check my work. Your test is not that many questions. The ones that you stop in point slope form, you can't do this. But the ones that you take to slope intercept form, which is honestly probably most of them, you can check your work. So I think it's definitely worth this to go put your slope intercept form in y equals, and then what are you looking for? What do we want this line to go through? We wanted it to be parallel. Does it have the same slope? Here and here? Are these the same slopes? Yes. And then what else do we want this line to do? We want it to go through. How do you know if it did, Miles? Once you put it in here, where do you go?
Second graph.
Thank you, Miles. Second graph. What does it say in blue above the word graph? Table. So you go look in the table and you're looking for that point. -4, +2. If it is there, check, check. You did it right, okay? And if you have a multiple choice question, you can do some process of elimination by checking your equations and y equals and checking the table, okay? All right, number 2, takes everything away. This is how it will be on your test. So I put a star right there. Okay? They're just going to give you a problem. They're going to give you space. And they're going to ask for slope-intercept form. Nick, you with me? You were gone last time. So I want to make sure you're caught up. So no longer do we have all these answer blanks. Here's how we're going to reason through it. We're trying to get to slope-intercept form. That's the goal. We want to go through the point 4, 2. We want to be what? All right, the first thing I'm going to do is write this. What does that sign mean?
Perpendicular.
Perpendicular. Okay, remember it kind of looks like perpendicular lines. Make a little right angle. I want the perpendicular slope. That is something that I have to have. So look at the equation that they give you. Y equals 4/3 x plus 2. Can you see the slope? Cruz, can you see the slope? How do you know?
It's right here.
Because it's in what? It's in what form? Slope-intercept, y equals, okay? But we want a perpendicular slope. So what do we have to do to this 4/3? Flip and change. How do we flip it, Jahan? Perfect. -3/4. The original guy was positive. Perpendicular's got to be negative. Flip the fraction. Okay? So that's what I need. That's the M I need to use. What's the point I need to use? That's in the problem. What does the problem say? What point? 4, 2. All right, where do we have to go before we can get to slope-intercept form? We have to make a pit stop in point slope, and you can call that PS to abbreviate. All right, y'all do it. Take it to point slope, convert it to slope-intercept. So do y'all see how I didn't have those little checkpoints, but I just kind of made them myself? I didn't even do all the stuff they did. I just kind of put my perpendicular and my point, and then point slope, take it to slope-intercept. Okay, guys, 3 and 4. 3 and 4 are the same idea. I think you guys can do this. However, what is different about 3 and 4 that makes these problems more work? Let's look at 3. We're going to slope-intercept form. That's not different. We're given a point. What's our key word? Parallel. Parallel lines have the...
Same slope.
But look at the equation that I gave you. Is that guy in slope-intercept form?
No.
So is that an easy take the slope, keep it the same? Hey, make sure you're listening. Is that an easy take the slope, keep it the same? No. No. What do you have to do? And y'all are going to have to do this.
Well, that's not pretty. That's not
You're going to have to convert what form? We're going to have to convert to slope-intercept form. Okay, and you're going to have some homework problems that do this. Most of the star questions that I've seen, they make you do this. Okay, so it's pretty important. It's not very fun. Takes a little bit of work, but we got to do that. So then you can identify the slope, find the parallel slope, boom, boom, boom. Okay, so we're just kind of building a little bit more each time. So go ahead and try 3. 4 is the same idea. They take away all those steps, but y'all got it. Think about what you need, and then go from there. Okay, I'm going to kind of work number 3 quietly in case you get stuck, but then I want you to try 4 on your own. I'm going to walk you through the process because this is how it's going to look on your test. It's going to be a problem and it's going to be an answer blank. okay? And it takes some space to get there. Number 4, you want your final answer in slope-intercept form. You want to go through a specific point, but you want to be perpendicular. The line that they gave you, you guys have to recognize that that is not in slope-intercept form, therefore you cannot see the slope. So you have to do the conversion. That is the first thing. That is a problem in itself. Now, when I converted that, I got 4x minus 5. What did I write in blue underneath the 4? What did I do right here? Look at me. I put it over 1. Why did I do that? Miles, why did we do that? Why did I put it over 1? Because I have to flip it. And to me, it's easier to think like, hey, if it's not a fraction, put it over 1. So that way I know how to get my perpendicular. And this word that I drew the arrow from, I would be circling that, underlining that, highlighting it, maybe even write, flip and change, like on your paper. So you make sure, because if you don't get this right slope, this is not going to be right, okay? Then I go to point slope form, then I go to slope intercept form, and I check it by putting my slope intercept form in y equals, checking for that point. But you've got to make sure that those slopes are going to be perpendicular of each other, flipped and changed. So this is like the whole process of that. We are going to talk about, let's flip over. If you did some of those, great. Let's flip over to page 16. Oh, actually, wait, I'm just told a little story. I want to use, you don't have to write this. I just want to show you an example. I'm going to write on number 2. If you did number 2, that's fine. You don't even have to write this down. I just want you to kind of watch what I'm doing right here, because I think you could potentially see this. I want to say it's kind of like this on your CFU on accident. We didn't mean for that to work. But what if this was my point slope? Let's do y, Mohammed, pick a number. Positive number, please.
8.
Plus 8, okay. Miles, pick a fractional slope. That's negative.
Negative
3/4. Okay, that's really weird because I was going to say that. Okay, x, Jahan, pick a negative whole number, please. Okay, that'll work. All right, so if this was my point slope, again, this is not this problem. So if you are writing this, make sure you are aware. This is just a random point slope here. I just want to talk about what would happen in this conversion, okay? So how do I convert, Ethan? What's step number 1 when you're converting to slope intercept form? What do you have to do? Distribute. All right, so I got y plus 8 equals negative 3/4 x. I'm going to go to my calculator. I'm not scared of fractions. And I need to do, when am I going to put my calculator for the next step? Anyone? What? Negative 3/4 times what? What kind of 3? Negative 3. Okay, and that gives me a positive 9/4. Is 9/4 a pretty number? No, it's not. It's not. But what do I do? Johan, what do I do next? Get slope intercept form. I distributed. Now what do I do to get y by itself? I distributed. So that was step 1. Subtract 8. Now I'm still putting 8 underneath this number that doesn't have an x. What do I do with that? 9/4 minus 8. What do I do? Put it in my calculator. Y'all know how to do that, right? 9/4 minus 8. And so I get y equals negative 3/4 x minus 23/4. Okay? Do you need to change that to a decimal? No. Could you? Sure, but I wouldn't. All right? That's a perfectly acceptable answer. So just FYI, if you do see that, it's okay. Just work it in your calculator. All right? All right, let's take just like a 2-minute brain break, and then we're going to go to page 16, knock this out real quick, and then homework time. And there's a little breakdown, and then we'll go to homework and get ready for the CFU. So sometimes they will ask us questions about being parallel or perpendicular to the x and y axis. So that means we're talking about vertical and horizontal lines. So while I don't think these problems are like that difficult to complete, the process is a whole lot shorter than the other ones that we've been doing, but we do need to make sure that you remember what these look like. and how to write these, okay? And so there's an acronym that I'm going to review here. We're on page 16 in the notes. 16 in the notes. So let's put that here, okay? We'll go that in a minute. All right, so let's look at this first one. It says to write the equation of the line and then complete the sentence. So let's talk about this line first thing, okay? What kind of line is this?
No
That's
fun.
the slope. That's the slope. But what type of line is it?
No.
How would you describe it? It's up and down.
Vertical.
That our math word for that is vertical. Y'all are saying undefined. You're almost there. It is a vertical line because it's up and down. We need to know this. Vertical line. What type of slope does it have?
Undefined.
That's what y'all keep screaming out. Vertical lines have undefined slopes, and that's great. That's a really important aspect of it, that it is an undefined slope. But we need to write the equation of it. So there was 2 more letters in our little acronym. Do y'all remember? V, U,
X.
X, and X. What axis does this cross over?
X.
The X axis. Now here's the most important one for writing. What is the equation going to be? X equals, what X value did you draw through? Which one? 8. So this is your answer. This is the equation of this line. Okay? You've got to know that vertical lines will be X equals. Okay? That's how you write it. You're going to have to write this on this test. Now, fill in the sentence. The line is blank to the x-axis. So let's look at the x-axis right here. Here's the x-axis. Look, there's a little x right there. The x-axis is this way. Our line is this way. How do we describe that relationship?
Perpendicular.
Perpendicular. And I would underline which axis you're talking about. You're talking about the x-axis in this one. They're perpendicular because they cross. Okay? Now, the next answer blank is talking about which axis? The y. So that's this guy. How would you describe the y-axis and the line x equals 8? Parallel. Are they ever going to cross? No. They're both vertical. They both have the same slope. That's all you have to do. Okay? But it's just we got to make sure we get those vocab words correct. And we got to make sure we know how to write these. So, this one right here, we'll go through this quickly. What type of line is this?
0 fun.
That's the slope. What type of line is it? Horizontal. Horizontal lines. What type of slopes do they have? 0 slopes. 0 fun. 0 slope. H-O what? Y-Y. Hoi vux. Hoi vux. Horizontal lines cross the y-axis, and their equation is, they didn't give us a very pretty one. What do y'all want to say that is? Y equals what? What? Negative 2 point, I'm going to say 2.25. How about that? So it looks a little bit closer. They put B, but we'll scribble that out. Okay, so y equals, again, the reason that it's y equals is because it's horizontal. Now, here's a way to check. Do you have a y equals button in your calculator that I've talked about a whole lot?
No.
Yes, you do.
Sorry.
So you can go type negative y equals negative 2.25 in your calculator, and you can look at it and make sure that it kind of looks like the picture that we've got. And if it doesn't look like the picture that you've got, then is it a y equals equation? No, it's going to be an x equals equation. And guess what? You don't have an x equals button. Okay?
I think the graph is pretty cool.
The graph is really cool. Really, really cool. So that's the equation. Now, fill in the blank. This line is what? To the x-axis. Here's the x. Here's our line. Parallel. Can you use the shortcut? Sure. All right. This line is what? To the y-axis. Y is this way. Our line's this way. What word am I going to fill in?
Perpendicular.
Perpendicular. Okay, you try these bottom 2. And then there is a little breakdown sheet on page 17. I want you to work on there. And then we will homework and we will get ready to CFU in about 15 minutes. Okay, fill out the breakdown sheet on page 17. And then your homework packet, you have the final page right here. Unless you were absent, you still have 5.3. But everyone else, y'all got all the way finished. So you have 4 problems on 5.4. When you're done, get those checked by me. And then we are going to start our CFU at 10:15. So that gives you 17 minutes to do 4 problems.